My name's Andrew Moore. We run a cattle breeding and trading operation in Niangala, New South Wales. Our cattle breeding operation is based around an Angus and Shorthorn base herd, and then we cross that with a Charolais animal, and our trading is mainly Angus cross, heifers and steers. Our rainfall here is about 1,000 mils per annum, and this southern side is getting up to 1,200. Our altitude is about 1,350 above sea at the highest point. Our permanent pasture base is based around a fescue pasture, but we're adding to those pasture species. We're trying to get as many grass and herb species in our pasture mix as possible. We put in plantain, chicory, prairie grasses, clovers, 3 to 4 types of clovers. We run a fairly rigid rotational grazing program, predominantly for pasture health, but also cattle health. We want to be between 18 and 20 DSE per hectare throughout the year, very much seasonal dependent. A lot of our development country, we started at a baseline of about 12 DSE per hectare. As we've increased our DSE throughout the years, we've noticed that the country isn't jumping back as quickly. They're mining the country quite severely. We're putting a lot of pressure on this country and we're taking a lot out of it. We're starting to look a bit more into our soil health, and that stems right through to now looking at what our soils are doing and seeing whether we can get those extra percentages out of the soil. So we need to put something back in, and the soil testing will give us that information of what's limiting and what's been taken out and how to address that situation. Otherwise it's just a guess visually, and you can get it very wrong. After the really wet couple of years we've had, I just want to see what our baseline is and where we are sitting and what our maintenance program's doing, and seeing whether we can improve on that with the driving factor of increasing DSE and the driving force of input costs. We just want to make sure we're not throwing money away for nothing and getting the best out of our money.
So in simple terms, you can't manage what you don't measure, or at least it's harder to manage what you don't measure.
Soil testing gives us a window to view what's happening below the ground, insights that are essential really for good farm management. As a diagnostic tool, soil testing helps identify nutrient levels, soil constraints and overall soil health. With this information, we can make informed decisions about rates of fertiliser and other amendments, crops or pasture selection, and broader management strategies. Repeated soil tests allow us to track changes, and we can see how our farming practices are influencing the soil. Lab tests therefore help us both maintain and improve the production we derive from soils.
Understanding the variability really helps you guide where you would apply fertiliser. Soils vary a lot across the landscape. They vary laterally. We can see that in the undulating landscapes. We can see that how colour changes and depth changes, but also changes down the profile. And that's one of the things that we're really looking at when we do soil testing and analysis, to see what the plant roots are experiencing in the topsoil, but then also as we get down into that bucket, how well they can grow in and through to access the nutrients that are there. You can see that in things like where you've got a dark layer on top, the organic matter. It's relatively confined to close to the surface and it depletes with depth. Things then change below that. You can have different levels of acidity, say, come through. Taking a good representative soil sample is really one of the most important things to do. There's so much variability within the paddock, but really it's important to get a good representative soil sample for what you're wanting to describe in the landscape, and also vertically, because the materials vary down the profile.
There'll always be a bit of natural variability, so the value of soil testing for decision making increases as a trend line emerges with the more you do.
We do set depth sampling to be consistent, but we also want to not mix up those layers, those materials too much, because we could have quite different properties that would then even out and not really tell us too much. And that's where we come to the idea of this finer increment sampling that we're looking at for acidity. So rather than just doing a coarse sample of 10 centimetres, which has been standard and has served us very well, we do see in places that there can be stratification where you might have either just the surface being quite acidic or the subsurface being quite acidic.
The idea of sampling finer 5 centimetre increments to perhaps 20 centimetres is relatively new in the wider industry. The objective with the finer increments is to help producers identify a constraint that a broader 0 to 10 centimetre increment, or not sampling deep enough in the root zone, may not detect. For instance, Here we have an example of how pH changes down the profile. If we were to only sample 0 to 10 centimetres, the result would show a pH of 5.1, which would be okay. By taking 0 to 5 and 5 to 10, we can start to see a more accurate representation of the pH. Taking deeper samples, we see the variation through the profile, and without doing so, we would miss the underlying band of acidity where we see the pH drop as low as 4.3, a level that would restrict the root growth of many plants. These finer increments pick up the acidic band in this soil at 10 to 15 centimetres, which then helps inform your lime application.
So having bagged our samples, we want to make sure that there's a good label on there so nothing gets mixed up. Seal them up properly so nothing gets mixed up, contaminated, and store them in the cool before we can get back to the lab or send them off to the for analysis.
A good reference for taking reliable samples is a guide for fit-for-purpose soil sampling by Cameron Goulet and David Weaver from 2019, put out by Fertiliser Australia.
One of the important things not to forget in sending your soils off to a lab is that the lab is accredited. A couple of systems we use in Australia, one is NATA and one is ASPAC. If a lab's got accreditation in both of those, then you can be fairly sure that the numbers you're getting actually relate to what you're sampling.
There are multiple test options available, so it's important to get good advice from your agronomist and the lab to ensure fit-for-purpose tests are used and the results are meaningful for each soil sample. With the results back from the lab, we have solid information to guide the application of fertilisers or other amendments such as lime. We have robust benchmarks that have been developed through a lot of research to guide application for critical levels of pH and for nutrients like sulphur, phosphorus and potassium, while minimising the risk of over-applying or losing nutrients.
We are in acidic soils generally. Our pastures are suited to those soils. The difference of getting from a 5.2 to a 5.5 in pH, what's the economic cost to that versus what pasture growth we're going to get?
All areas are worth investigating and assessing more closely to see what is it that's supporting the areas of good growth, and where areas are marginal, even in just the variability in the paddock, what is different about those. It does take time to go and get a good sample, but having that information really then helps guide how much input is required, how much money that's going to cost to either lift or maintain levels, or save money by not needing to apply high rates. There can be a standard practice that people have just put on, the rate of P every year or every few years, and that can actually have built up quite high levels. If there's enough P in the soil, for example, throwing more P at it is not actually achieving anything. There's only so much growth that you'll get for a plant in a certain environment. Even more so if there's other constraints, like there's acidification where the plants can't actually grow through the soil and access the nutrients, then throwing more of one at it isn't going to address that problem. You need to have that more fuller picture of what actually might be constraining.
We need to start getting a bit more longevity out of our permanent pastures, and so soil health will get us our 20 to maybe to 30 years out of a permanent pasture instead of the assumed 10 at the moment. The area we chose to do first is essentially the oldest pastures we have for finishing livestock, and so they're probably coming around to being redone. They're pushing 20 years, and so if we can assess them and see whether we can just get a few more years out of them, I think that's a more economic way to go about it, by feeding the country instead of redoing the country.